Okay, so obviously you guys yesterday seen my last video. I'm doing them all in one day, like I said yesterday. But this video, we already did recessive, which was 2 days ago. Yesterday was codominant, and today is dominant. So I swear to God, I did not honestly intend to do that, but I'm gonna keep it in there. Why not? Anyways, so dominant genes when it comes to ball pythons. Get away from me. Okay. Typically, you have it's common knowledge that spiders are dominant genes. But it's actually been documented. Get away from me, fly. What the heck? It's actually been documented that you can produce a super spider. So spider is technically a codominant gene. However, as most people know, spider has neurological issues. And that's not saying just spider. For instance, you have that problem with champagne, with woma. I've experienced that problem with hidden gene woma. And there's a few others. I can't list them all. There's a few others that also carry neurological issues, and not only neurological issues. However, if you breed at least spider and champagne, if you breed a champagne to a champagne, that is known as a deadly combination, meaning that your offspring will die. If they do not die inside the egg, they will die shortly after coming out of the egg. And that's the same thing with the super spider. They have had documented cases of fully developed animals that have either, again, died inside the egg or shortly after hatching. As I stated in my intro video, 3 days ago or whatever it was, I actually had planned on doing a deadly combination before I knew it was a deadly combination. And thankfully, I researched more about that. I did have somebody tell me about the issue, and then once they told me, I did research. I found out what everybody was talking about, and I decided to go against, or not so much against, I decided to change course and turn away from that project and just use those animals as different projects in totally different aspects, which I am thankful for, because obviously if I would have done that and it would have been a deadly combination, obviously not only would I have felt bad, but then it's just, it brings a lot of it just brings issues just across the board. It's not really worth it, guys. It's really not. However, you do still have people that will tell you that spider to spider is okay, and no, it's not, guys. It's not. Spider to spider is a deadly combination. I cannot answer if pinstripe to pinstripe is a deadly combination. I don't think that it is, but I honestly have never even thought about pairing up the two together, so I have no idea. Which, doing something like this, I probably should have researched a little bit, but it's okay. At the end of the day, again, when it comes down to dominant, people will say that spider is a dominant gene, and I really think that that is to discourage people from trying to breed spider to spider. Pinstripe is a dominant gene, but if you have, say, a pinstripe to a normal, which is also considered a dominant gene, you do not get a normal pinstripe. You do not get 100% pinstripes. You do not get 100% normals. You do not get 100% normals het pinstripe. Those are not things. When you pair a pinstripe to a normal, you're looking at a 50% chance of your clutch being pinstripe and 50% being normal. If you pair, say, a super pastel, which is a super form of the codominant gene of pastel, to a pinstripe, you will get lemon blasts, some will be lemon blast, and some will just be pastels, because with the super form you will minimum get that single codominant gene. In this case it would be pastel, and you have 50% chance of getting pinstripe. So again, you can interlock those, not so much interlock those, but 50% of your clutch will be lemon blast, which is pastel pinstripe. The other 50% will just be pastels. Nothing wrong with that, but that's just how the cookie crumbles. I don't know why they call them dominant. Not so much why they call them dominant. I'm not sure the science behind it, why only 50% of the animals will look like this or look like that, whatever. It's basically the same thing with the codominant genes. However, with the codominant genes, you have the ability to produce a super form, whereas with the dominant genes, you do not have the ability to produce a super form. But that's realistically that when it comes to dominant genes. I've talked about the recessive, I've talked about the codominant, and this video is the dominant. Hopefully you guys like this series. There's going to be a few more videos dropped below. If you guys have any questions on which animals are dominant, leave a comment down below and I will try to answer them for you guys, as I stated on the last two videos as well. Please do not ask me to list a bunch of animals that are dominant. To be honest, with dominant genes, there's really not too many. However, I just don't feel like going through a list just in any format. I don't want to go through a list of dominants, codominants, or recessives. It's complicated. But be on the lookout for the next video, and we'll talk more about different combination problems. So if that's something that you guys want to see, just keep an eye out. Alright guys, take care.